Yep. Screen share. Oops. I don't know how to get rid of that. Maybe I go over here. Yep, there we go. Okay. All right, so welcome to class today. Half the class has gone up here, which means one person's gone. So I have a few announcements. First of all, I updated the entire course website. Instead of referring to things as weeks, because we've had a few off weeks this semester, I changed them all to M, which stands for meeting. Meeting 1, meeting 2, meeting 3, meeting 4, meeting 5, and so on. So today we're at meeting 7. Okay, we did meeting 6 last week. If you click into here, the contents are all the same, except I just changed the word weeks to meeting. So here's the one on building toolboxes, okay? And then today we're going to do this one, which is titled Working with GIS Data, okay? So simplify it a little bit. I don't know if simplified is the right word. I called it, I think meetings is a better word anyway. So probably going forward, I'll continue to do that. The other thing is I hashed out the schedule so that it actually matches. So we had, we had our class where we had the bad weather data where it was canceled, the bad weather day where it was canceled. And then the next week is where I put the one that I did virtually, like I was upstairs in my office upstairs in my house, where I recorded that one. That's where we started talking about doing ArcGIS with Python. We reviewed a lot of that last week too. Then I planned to do another video, but the internet never really worked out well. Then I got sick when I got home, so I dispensed with that other video. I spelled ArcGIS wrong, but we did our toolboxes last week. That was meeting number 6. And today we're down to manipulating vector GIS data and exploring and manipulating spatial data, which I shortened in the actual lecture. All right, so we're going to have one more week where we practice dealing with basically vector data and toolbox next week. And then we'll move on to raster data. We'll talk about raster data for a couple weeks, and then we'll finish off the course on April 26th using GIS scripting with other programs. And then the final exam will be May 3rd, which is the last day of class. I probably will, because this is a class on programming, I'll probably give an assignment on April 26th. And it may or may not actually be due on May 3rd. I'll probably make it due as late as I possibly can and still be able to grade it. So it'll be due sometime this last week, but it may be almost up to almost a week after that. Let me try to give you a full 2 weeks. All right. So because I don't have to assign grades until the end of the regular semester, we're fine. So this is technically a night class. That would be the last day of class. And so what we'll probably do is maybe I'll change this to reflect it. What we'll probably do is I'll give out an assignment on April 26th that will constitute the final exam. And then on May 3rd, we can basically set up the broadcast. So if anybody's working on the assignment and has a question, we can do that during those 2 hours. We wouldn't present any new material. There wouldn't be any point in presenting any new material on the last day of class anyway. All right. So that's the schedule as it'll play out for the rest of the semester. Basically, we're going to do 2 weeks manipulating GIS vector data and 2 weeks manipulating GIS raster data, and then we originally had planned to do 2 weeks of basically coupling using ArcGIS along with other programs, but we'll just do one. Or one less week than we got to the semester previous, which I think is pretty good considering the bad weather data. Bad weather day, why don't I keep saying data? All right. So this is at the course website. It's down, scroll down. This is kind of like not kind of like, this is the syllabus for the course, and I just updated it with the new schedule. And I should probably, well, I did, sorry. I put the M number next to them, so now you know which meeting is associated with which lecture, so we don't have to always think, was that week 5 or week 6? Was that week 6 before we missed the class, or week 6 after we missed the class? We're just going to call them meeting 1, meeting 2, meeting 3, and so on. So this M7 today, if you scroll up, is M7 here. So, any other question about the schedule? Will make a little more sense than using weeks instead of. Sorry to switch it mid-semester, but I think it's a good choice because of. By the way, the week numbers are the same as the meeting numbers. So I didn't renumber anything. It's just instead of calling it week 5, I called it meeting 5. But there's no new numbers. So we did week 6 last week. Now it's called meeting 6. It's still technically due 2 weeks from when it was presented. So that's next week. All right. So meeting 7 today. All right. I have some data that we're going to talk with. But today we're going to make a little bit of a change. We've seen basically the ability of Python to run ArcGIS commands. That's what we've done so far. We've ran ArcGIS commands from Python, and that's actually really powerful. We can couple together lots of different commands and create a script that does something pretty unique. In fact, just today, one of the other graduate students in our department, Chris Hare, said, "Hey, Dr. Aber, I got this problem. I've got 1860 county boundaries and 2000 county boundaries, and I want to basically estimate the number of slaves that lived in every county today by using the population of today." But the problem is that the 1860 boundaries are different. Most of the time they're bigger. 1860 county boundaries are larger than 2000 census data. Does that make sense? And actually what I told him, the solution that we came up with was very, very similar to what we did in last week's lab, which was kind of funny. Except we weren't doing watersheds and census tracts. We were doing county boundaries in 1860 and county boundaries in 2000. And so we just came up with an estimate of how many people lived in those older counties that were larger. We did that by kind of dispersing them evenly based on the area. And then we made an estimate. We did take it a step further because we then made an estimate of the slaves, but we used the population to determine where those slaves might have been living. And again, it's an approximation. But again, because the county boundaries in 2000 are, for the most part, smaller than they were in 1860, it's not a horrible, it's actually a good way to do it. And it was supported by research. In fact, he came to me with a paper and said, and I said, oh yeah, they're basically doing what we did last week in a lab. Now, it just took Chris and I about an hour to press all the buttons in ArcGIS. If I would have had more time, I probably would have said, hey, let's try to write up a script, and then we could do this for lots of different areas. Okay. I guess we're only interested in the south, but we could have done in other areas. But that's the power of being able to link together these ArcGIS commands. Okay, we'll practice that a little bit more next week. Next week, we're actually going to combine what we do this week and what we did last week, or the last 2 weeks, combine them together one more time just to review the concept. And but this week, what we're going to focus on is actually manipulating the fine-grained details of GIS data, rather than saying, you know, run a buffer, okay, on this data set. What if I wanted to shift the position of just one of my let's say I had a bunch of point features, a bunch of points. They might represent fire hydrants or something, and I want to programmatically shift the position of just one, or I want to programmatically shift the position of all the point features. Let's say I live in Los Angeles, and the earthquake has just shifted all of my whole city, and I need to change everything by 0.3 meters. I need to move everything 0.3 meters in one direction, every single data set. And that might be a little bit of a silly example, but there are real world examples where we need to move everything in our data set just a little bit, okay? And there's not a really clean way to do that inside of ArcGIS, but there is a way to do that in Python using a script. Also, that's the spatial data. But what if I wanted to change the attribute data or multiple attribute data based on some other arbitrary criteria that I came up with? Well, there is a tool called Calculate Fields that I could use. But if I wanted to do this as part of a script, there is a way to do it. So basically, we're talking about manipulating our GIS data. And that's what I meant when I said, what is GIS data? Okay. And we've got two things that constitute GIS data. We've got our spatial data, which you can see from the outline what I'm talking about when I say that. Points, lines, and polygons. In ArcGIS's world, can we have mixed point, lines, and polygons if we're talking about one data layer in the ESRI realm? Can I have a data layer that contains points and lines? No, you can't. Yeah, that's true. Okay. There are some data models that do allow for that, but ArcGIS doesn't allow for that. So we've got points, lines, or polygons. Points or lines or polygons. And so that works out pretty well because we know we don't have to check. We're writing a script, we don't have to check everything that we're looking at. We know where we're dealing with points, lines, or polygons. So one thing that we need to think about when we're actually going to manipulate points, lines, or polygons is we need to think about what a point is, what a line is, and what a polygon is. What's a point? It's pretty easy. That's pretty easy, right? Right, and how do we define that in all GIS systems, not just ArcGIS? Right, and so it's basically a set of coordinates. Typically, or I should say minimally, that means two coordinates, a latitude, longitude, or an X and a Y. Okay. However, points can have multiple dimensions. ESRI allows you to store up to 4 coordinates in a point. So it allows you to store a X, a Y, it allows you to store a Z, and then it also allows you to store an M, okay? I'm not sure why they chose the letter M, but points can have M. Right, it's just a 4th dimension to the point, okay? So it could be used to store any other attribute. Almost always, or I should say, M is rarely used because we have the ability to store an infinite number of attributes in the attribute table. But there are some cases where it becomes important. Okay, so what's a line if a point is a single coordinate?
Set of points in a straight or in some sort of.
In ArcGIS, it doesn't have to be straight, but technically in mathematics, a line would be in a straight line, right? But I'm talking about a polyline here. Maybe I should have written that out. A polyline is a set of points. Okay. Now, almost all GIS systems today will actually allow you to have in what's called a polyline. I'm doing air quotes here. In what's called a polyline, it will allow you to have two lines that don't even touch each other, and they can still be considered the same line. So a polyline is just a line feature, and it can have multiple lines coming off of it, okay? And it would still be called a polyline feature inside of ArcGIS. Okay, so those are called parts. Okay, so a polyline can have multiple parts, but all the parts are made up of points. So we've got points, and then parts, and then that makes up a polyline. The same thing is really true with a polygon. In fact, there's no difference on the disk or in memory between a polyline and a polygon, except for the fact that the software is telling it you're a polygon, not a polyline. And so the software knows to interpret the polyline, or the polygon, sorry, as closing itself. Okay, so polygon basically completes itself, and so it has an interior and an exterior. Okay. So I had some pictures for this polygon GIS. Got any good pictures? All right, yeah, here's a really good picture. Okay, so a polygon has vertices, which are points, and if we have a single vertice, if we have a single series of points, we have one part. If we have two series of points, we have two parts. And ESRI will actually interpret, or in fact most software does, will interpret a part inside of another part as a donut. Okay? But this is just this is just the first part, this is the second part. Okay? If the second part is outside of the first, it just interprets it as a discontiguous area. An example of this is like Michigan. Michigan could be considered a two-part polygon. Okay? All right. Are there any other Hawaii would be like a five-part polygon. The United States of America, depending on if you just talked about the states themselves, would be at least a three-part. You know, the continental United States, Alaska, Hawaii, and perhaps Puerto Rico and the U.S. Virgin Islands, and all that part. So anyway, we've got parts of polygons, and polygons are made up of points. So we'll implement this. We'll show how that ArcGIS does that. All right. Okay, now table data is really, really simple. It's just attribute data that's listed out in what's been called for a long time a flat file in GIS. Okay, so flat file means that we've got rows and columns where the rows represent in GIS. What do we call those things?
The way she pronounced it was really funny. I can't remember what it
Well,
was.
there's multiple words for it.
Yeah, but what our car used for it, I'm trying to remember it. It sounded funny in her accent.
Right. They're the things.
Yeah.
The entities in the real world. They're separate entities in the real world. Lots of people would refer to them as the features. Okay, that's what I would. That's kind of what I was fishing for if I was fishing for anything. The features. Okay. Now the columns. What do they represent? Yes, the columns represent attributes. Okay. So what we're talking about today, one of the things we're talking about today is if I want to access an individual row and column or an individual attribute from a specific feature in ArcGIS, I can do that in Python. There's a way to do that. Or alternatively, I can access every attribute for a specific, well, I could do every attribute. More often, you want to access the attributes for every single feature. All the attributes of one column for a specific feature. All right. Now, the thing that makes GIS powerful is that it links together the attribute table and the attribute data and the table data. So when we access this data in Python, the points, lines, and polygons are just another attribute of a feature. Okay. So when we say, okay, I want to go through and look at the shape attribute for a feature, what we're saying is we're just looking at a particular column of data. See that here in a second. Well, let's get started right now. Okay, I'll leave this second part for later. And we're also not going to talk about raster data is different. We'll talk about that in a couple weeks. So far, everything I've mentioned is vector data. So let's start messing with vector data. So what I'm going to do is, I haven't done this yet. Should have already done this, but I didn't. Is download the data that we have for this week. I have two data sets that we're going to experiment with. Only one of them for the lab. The other one is for the lecture. One is cities data set of Mississippi, and the other is a data set that is basically made up. It involves some tracking data for animals. That's what it purports to be. All right. Should have already done this. So give me a second here. SPA. I'm going to download, because I made all those changes on, make sure my local copy is the same. Yeah, okay. So now when I open up SPA on my local drive, it'll have all those changes. We're on week 7, and I have the city and the M7 data. These two data sets are what we're gonna mess with. Okay. So I gotta unzip these, and I'm gonna extract them. I'm just gonna take these data and put them on the C drive. So copy, I'm gonna put them on C temp. The reason I'm doing this is that if I don't put them somewhere else, then when I try to, whoops. When I try to upload it later, it'll try to upload all the not zipped copies. So I'll call this M7 or meeting 7. Okay. And then do the same thing for this data set. Control A, copy, put that under C, temp, M7, So now I have all that data. I probably should have all just zipped it up into the same directory, but I didn't. Okay. I'm going to look at this data actually in our catalog. We'll look at the city data, and then I'll look at the GPS points data. I'm not going to look at well, no, I'll look at the parks data too. Make sure I got my phone turned on. Okay. So C, courses, SPA. All right. Oh, that's not where I put it. I put it in C temp M7. Okay, so here's the city data. It's not going to look like much, but if you can see the outline of Mississippi. Those are all the cities in Mississippi. And if I switch to the table, you can see these are the attributes. Okay, we've got the shape. See how this column called shape? So inside of this attribute, like I'm highlighting, see the dark black box that appears there? Okay, that says polygon, but stored inside of that black box is a description, a bunch of coordinates that constitute the coordinates for whatever that row is. So in this case, it's the city of Natchez. Okay, it's Natchez right there. That polygon represents the city of Natchez. Okay. And we've got all of the cities in Mississippi and a bunch of other data inside of them. Okay. All right. The GPS points, that's the way they look. These are animals that have been wandering around, and every 10, 15 minutes it sends out a GPS signal of where they are. And so we've got some animal systems. Here's some parks that represent national parks that these animals are walking around in, and that's it. Okay. All right, so what we're going to do now first is to just explore how we would access some of this data using Python. Okay, so going back to here, we're going to jump down to number 3. We'll come back to this later. Okay. This should say implementing, not spelled right. Okay. The way that we access the data is through a specific module within ArcGIS called the Data Access Module, or DA. And there's a whole help section devoted to this model. And we use that model to get into the data. And remember when we went over accessing files, we could open up files for, what were the 2 modes that we talked about to open up files? We used open, but when we opened them, there were 2 ways we could open files. One was for reading, and the other one was for writing. That's what I'm talking about. All the answering of questions burden is crazy, right? All right. So yeah. So the reading and writing. Similar, there are different ways we can open the attribute table of a GIS data layer. We can open up the attribute table of a GIS data layer using search, insert, or update. Okay? Those are the 3 things that we can do to open up an existing GIS data layer. Search simply allows us to read the information inside of a GIS data layer. Insert allows us to create new rows inside of a GIS data layer. And update allows us to change the values in a GIS data layer. Okay, so update doesn't allow us to add new ones. Insert does. Search doesn't let us change anything. So if you're opening up a layer and you know you don't want to change anything, you better do search, or you should do search, because there's no way to modify or change the data using a search cursor. So if I hit this button, I'm going to get some help. Oh, I made this. Let's see if I can just change this. Now, we only have 10.1 on our machines up here, so this isn't bad to be on the 10.1, and nothing's you can use the 10.1 help in 10.3, but if that doesn't work anyway. So just use the link I provided, because it's going to work just fine. Oh, I guess you could hit that button. All right. Now what we want to do is, if you go to classes, you'll see that we have an insert cursor, a search cursor, and an update cursor. These are the ones that we want to mess with. We'll start out with the search cursor. X that out. Start out with the search cursor, and it tells you the search cursor establishes read-only access to the records returned from a feature class or a table. It returns an iterator of tuples. In other words, it returns your attribute data as a series of tuples. Now, do you remember what a tuple is? It's kind of like a, you're right that it can be a pair, but it can actually be a sequence of any size. So a tuple can be a sequence of any size. Okay. So it's going to be a bunch of tuples, and the tuples will represent, each tuple will be a whole row of your attributes. So if I go back to here, go to table, when I create a search cursor, it's going to give me this whole row as a tuple. So 0 will be this one, 1 will be this one, 2 will be this one of the tuple. And then if I go to the next item in the iterator or the list, there'll be this one, and so on, down all the list. Okay, so let's put that into practice. All right. So there's a help down here. I'm just going to copy just this whole thing, copy and paste that into IDLE. File, new file, and paste that in there. Remember to do a new file. Don't try to paste it into here or it won't work. Okay. Well, it kind of looks like it did something, but didn't cause any errors. But that's not what we want. We want to copy it into a new window and then hit File, Save As, and save it somewhere. I'm going to save it to the directory I've been working in so that it'll go up on there, and I'll call it 2016 example1.py. There's some things that have to change in here. First, I want to change the location, because that's not the location that I'm accessing. I want to actually access the city's data. So I need to find out where I put my city's data and copy that into here. So this should be the path to the city's data. Remember to put an R in front of it. So this says, okay, the feature class I'm going to work with is the city's data. Okay. Now, the next thing is you need to give it a list of the fields you want. Okay. These are all the fields, and you need to give it a list of just those fields that you want. Let's see if that's optional. I've forgotten if it is. Field names. Okay, a list or a tuple of field names. For a single field, you can use a string instead of a list of strings. Use an asterisk instead of a list of field names if you want to access all the fields from the input table. So if we want all the fields, let's start off with that. we just put a asterisk. Okay. Now, it does say for faster performance, it's recommended that you don't do all the fields. Okay. Let's do that though. Let's just say, give me all the fields. So just put an asterisk in here. Don't know if it's like that or what. We'll find out if it gives us an error. Okay. So we're going to get all the fields. Now what this does, what this next line does is it says, with this search cursor that you're going to create, we're going to iterate, we're going to do a loop over the fields as a cursor. We'll get to this. Let's, I'm going to comment out this. Okay. Comment out those 3 lines. We'll get to that in a second, but I think a better way to actually show what this is doing, let's explain it a little bit better. So what I want to do first is just say cursor equals that. And this line is very similar to that, but I just want to show that a little bit better. Okay. And then go for row in cursor. First, I'm just going to say print row. Okay, so now it says cursor equals arcpy.da. Remember, this is that new module that we're dealing with now. Dot search cursor. And we need to feed it the name of a feature class. Here's the name of the feature class. We need to feed it the list of fields. We're going to say we want all the fields, and we're going to just loop through all the rows. Okay, I'm going to try to run this, but I'll put it in the other window. So invalid syntax. But we have to put this in quotes. All right. Okay, so the asterisk had to be in quotes. All right. Now, there is a lot of information here, right? Like, what is all this stuff that's going in there? See all these, this looks like a bunch of gobbledygook, doesn't it? Did yours do the same thing? The path? What did yours do? Like just cause an error or do absolutely nothing? Did it return you to the prompt here?
No. Mine had a runtime error.
Okay, what does the runtime error say?
Line 9 in module. It's the cursor equals archive.da search cursor.
Okay, that line had an error.
It's FC. Yeah, I don't know what I did.
Okay. Yeah, when we got time. There's only 3 people here. Why don't you both just send me your script to graber@gmail.com. So send me your script. We'll take a look at it. Figure out what's going on.
You have your city file inside the set folder. I have 2 separate folders.
It doesn't really matter as long as this path is correct.
Yeah, I know. That's what I have 2 separate folders. So it's trying to look at this folder for the thing that's over here in that folder. That's my problem.
Mm-hmm.
Which email do you want to Dr.
Either graber@gmail.com or george.raber@usm.edu. Those both go to the same place. That's my Gmail account. I already got the one from Kristen. All right, so let's take a look at Kristen's here real quick. All right, here's worked. All right, so I'm gonna look at this one. Oh, okay, so one of the things is, I said, for now, let's just comment this out. Maybe we'll over that quick. So let's try to run this. See what happens. Oh, your path's going to be different. That's not going to work. Oh, so Chris, you can see this line right here. You need to change that line to your city's data. So, for example, mine was right here. Wherever you unzip that city's data. So now I run this. Okay. Oh, I gotta put an R in front of it. All right, so that worked. So your only issue was this line needed to be fixed up, and then you needed to comment out these three lines for now. Okay. All right, so let's look at the other one. Oops. All right, so Bryce, with yours, it looks similar, except for I'm not sure exactly why it's not running, except for the fact that it doesn't see the data at that location. Like, so you've got a path that goes to see users, and then this. Maybe if you put an R in front of this.
I tried looking up, still not doing anything.
Still not doing anything.
You might want to check his folders on his desktop to see that the city.
I'm gonna move it somewhere else.
Yeah.
So I can do it.
You might want to move it somewhere else. Now, you did unzip it. It's not just. Okay. Yeah, I mean, we did have that problem last week trying to write to that desktop. Or yeah, well, we're not writing anything this time, but it's having some issue. It's having some issue getting there because everything else runs for me. The only line I changed to get it to run was this line. So in both cases, we had that line changed. Okay. So we do get a bunch of just, it looks like gobbledygook, but if you actually look at it, in fact, I'm going to look at the very last line here. So the last line ends in 1142, and we've also got Gulfport City. You see that? So that's how it's Gulfport. Let's look at the very last line in the attribute table. It says Gulfport, and it has the attributes 1142. So we are actually pulling the attributes out of this attribute table. In fact, if you go back up, we got negative 89.07. That says right there, negative 89.07. That's that number. So we're accessing the values in the fields. All right. Christian and Bryce, were you able to run it at all yet, or still having issues? All right, let's look here. All right. Where did you, it is supposed to be a shape file, yep. I mean, you need to have all of the files and not just the SHP file. Like, this is supposed to be the path to a shape file. Sorry, go ahead.
It's just the one zip folder, right? It's the IHN, or do I need anything else from the website?
No, you don't need anything else. So let's say, yeah, okay, so you're going to the course website here. Oops. Course website here. So here's week 7. And then, sorry, this is week 7. And then if you go to cities10.zip, download it, hit view raw, comes down, okay? And then you see it like right there, right? Then you click into it and grab everything, copy, and paste that into a folder.
Should I maybe try it off my flash drive or something?
I suppose it wouldn't work. I suppose it wouldn't hurt. So now I'm copying this into that location, and I'm running it again. Now, ArcGIS isn't producing any errors anymore, right? Let's say like you can't open up ArcGIS. No, I know up here it works, but down there. If you open I got a letter, I got an email from Dr. Holt today saying that it was all good to go in the lab. So hopefully. Bryce, your error is still just that it does nothing.
It just does nothing. It just it runs, but it says the Python 2.7.5 default thing that sits at the top of it. Doesn't do anything.
So kind of like, what version does it say of Python?
2.7.5.
What's yours, Caleb?
Hers is working.
The top of the Python, should see where it is on here. Okay, doesn't have a number. So yours is working now, Kristen?
2.7.
Yeah, I'm just supposed to have the same, like, code in the shell, right? Like I guess that's not really supposed to do anything else except for like calculating it. Gather all the.
Yeah, right now all it does is put all this blue text into the shell. See like that? Does yours do that?
Yeah.
Okay. Yeah.
272.
What's that?
272.
Okay.
Instead of 278.
That's fine. I mean, that shouldn't be a problem. The stuff that we're asking ArcGIS to do has been able to do for a few years. Okay. I'm still thinking, Bryce, that it's, especially now that it works on Kristen's machine, I'm thinking that it's something to do with the location of your data. Especially since it's not producing any errors, it sounds like what it's doing is it doesn't see the data, and so it creates a cursor that's empty. The cursor, remember, is just that iterator of tuples. So it's creating an empty one, and so when it enters, what does a for statement do? What's that?
There it goes.
Oh, yes.
It's a loop.
Generates a loop.
Yeah,
Sorry.
it loops. Yeah. So this for statement generates a loop. And each one of these rows, remember from the help, is a tuple. We can actually prove that by saying, what's that, type, I think. Yeah. Oh, great.
The asterisk is something that gathers all the fields.
Exactly. It says, okay, we just want all the fields. So what if we just wanted the city name? Like we wanted to just list all the city names. What's the name of that field? Name 10, it looks like. So if I write name 10 instead of the asterisk, and I run this again, it's just going to go, and it's going to go through each row and return the name of the field. Okay, I mean the name of the city. See that? So I've just made a loop and gone through each of the rows, but this time I've only returned the city name. If I also wanted it to return another field, I could just do that with another field here that would make sense. Population or something? Is there?
State.
Is there a state?
State key is 28.
Oh, okay, so it's a code.
So the area of wind and water, AL.
Yeah. Yeah. Okay, so A land 10. I could also say I want A land 10. And now I'm going to get a tuple where the first one is the name of the city, and the second one is the area of land. I don't know what area land 10 is. So now, yeah, something like that. Oh yeah, okay. It's the Maris data. All right, so now what if I only wanted to print or to show this item, not the name of the town? If I only want, right now I'm printing the whole row. What if I only wanted to show this item out of, because what is row? Remember I just showed you what row was? What type data type? What's a data type of row? Well, it contains all the attributes,
Yeah.
but it is a tuple, right? Okay, so it's a tuple. What if I only wanted to get the second item in a tuple? How do I do that?
How do you do what?
Get the second item in a tuple.
One in the bracket.
Yeah, like this.
Yeah.
So now I'm just printing the second item of that tuple.
To do this.
Well, yeah,
I'm
exactly.
making brackets with my hand.
See, now I'm just getting the second item. Now, if I print 0 here, I'm just gonna get the city name, and it'll look formatted better. Okay.
It's an easy way to extract
Watch that.
just a list of cities from that data.
Yeah. So programmatically extracted a list of cities from that data. Okay. So I can get all the fields with star, or I can actually list out just the fields I want. So here I've listed out the name and the area of land, and it's like you can never get comfortable in here. It's either too hot or too cold.
Because the sun's not shining today, that's why.
All right.
Last week it was.
Okay, so going back up here for a second, this is just fancy talk for the exact same thing we did here. It's just fancier Python. I don't know of a better way to describe that. But this syntax right here is using a keyword we didn't talk about this semester, so that's why I rewrote it. But with is a way to say, okay, I want to create a cursor for using this command, create a cursor, and then I want to do something with the cursor. We just wrote this in more, actually probably more plain Python. This still created a variable called cursor. Both of these created a variable called cursor. We then wrote for row in cursor exactly like they did. So this line is exactly the same. And finally, this is just fancier Python for printing out the first 3 elements, 0, 1, and 2. This is just, so what, this is the equivalent of going like this, row 2, or row 2, or row 1. We don't have 2 variables. Okay. So now I'm printing, oops, I put rows, not row. All right, so this is just the equivalent syntax to there. It does the exact same thing. Okay. Finally, the only advantage to doing this is that what happens to the variable cursor when this loop completes here? Well, you don't know. What happens to the variable cursor? If I said right here, print cursor, put something print right here. Yeah, who knows what it is, but something would print, right? Because cursor still exists. If you did this syntax, the nice thing is that cursor gets cleaned up. So after you run this statement, cursor gets deleted, bombed out, it's gone. You can't use cursor anymore, which is good if you're using an insert cursor or an update cursor. What it does is it says, I'm done using that cursor. You can go ahead and save it and close it. Remember when we did files and we wrote things to files? We did the file.close at the end, right? So it's the equivalent of that. If you write your code like this, which is actually the way I usually write it, you have to put one more line of code in, del cursor. So if you write your code like this, you don't need to type this. But if you write your code like this, which I think makes a little more sense, so that's the way I do it, plus we didn't really use the with statement, you have to write del cursor. And what that does is it deletes the cursor explicitly. Because in this code, the cursor is implicitly deleted. as the code runs, it knows as soon as I get out of this with block, I need to delete anything that I created inside of there. Here, you have to delete it. So now when I run it, I've deleted that cursor. For a search cursor, it doesn't really matter that you deleted it or not. But for an insert or update cursor, this line of code does matter. Well, return cursor would be if it was part of a function. But it's not part of a function. Sometimes it's even good practice to go like this. Oh, like this is being cut off? There you go. A little better. All right. So what we've done here is equivalent to this. So this is just the way I like doing it. This works too. This is the way most of the help is written. But either one is fine. So what we've done is practiced accessing data in the table. Okay. All right. Now, what if we wanted to access the shape data? Let's go back to the help for a second. Let's put that. Yeah. There are a couple of options for getting the shape data. And these are all the options that you have to get the shape. Okay. So here is, you can get, if you type in for the name of the field you want, if you type in shape at XY, you're going to get a tuple of the features centroid. Now, if we're dealing with cities like we are, the centroid is going to be a point that's inside of that polygon, right? What if we were actually dealing with point features? Where would the centroid of a point feature be? Exactly. So if you're dealing with points, you can just type in shape at XY and you'll get that. Let's practice what I'm talking about here real quick. So if I type in shape at XY, I'm going to get that. And now I'm going to run this. And instead of getting these two attributes, I'm still going to get the first two attributes, but the first one's going to be, you see what the first one is? Now the first one is an XY coordinate, and the second one is the name of the city. See that? So we get an XY coordinate. What coordinates are those in? Anybody? Those look like the latitude or longitude. It's MSTM. So it's a Mississippi transverse Mercator projection. That's what Maris delivers its data in. And we've got an X and a Y for that data set. So those are the centroids of every city. Okay. What if we didn't want the centroid? There's several other options. We can get the true centroid. We can get just the X coordinate, just the Y coordinate, just the Z coordinate, just the M coordinate. We can get shape at Jason. Let's see what that does. That's going to be a bunch of hard to read information is what it's going to be. But we're going to get it anyway. So I'm going to run this. Maybe it's just too much. Oh, it is printing it. Okay, it's printing it off really slowly. But all of these points are all the individual coordinates for the data itself. Okay, so these coordinate points is, so the city, whatever, so Braxton, there's McGee, there's Mendenhall. These are all the coordinates for Forest, for Morton, all the way down Heidelberg, Bay Springs, Philadelphia. These are the coordinates for each of those cities. All the coordinates in a format that's called the JSON format. Stands for JavaScript Object Notation. Why would that be useful? Well, let's say you were designing a website. Almost all websites, almost all mapping APIs, so like there's a course next semester called web mapping. Almost all web mapping APIs will let you import JSON into them. So you could have these features and feed them into a website if you used if you said add JSON. Okay. WKB is an open source standard for sharing data. WKT is too. The only difference is one's a binary format and one is a text format. All right, not the last one. You can actually just get the area or just get the length. The last one here that's just shape at with no other qualifiers is going to give you a geometry object for the future. And this is where you could then ask the geometry object for its parts and so on. So I'm going to do that real quick to show you what this is going to do. So if I just change this to geometry at and run this again, now it's going to print off that bracket or less than sign, geometry object, yeah, see that? Geometry object at, and then close bracket and tell you the name. So it's a geoprocessing object that contains a point line and a polygon. If I want to I'm going to save this right now. I'm going to go save as example2.py. Okay. So now I've got example 2, and I'm going to inspect row a little bit more, row 0. So what I can do here is say shape, oops, up here, shape equals row 0, shape does, okay? And I can say for part in shape, print. I don't know if that'll work. Let's make sure that works. But I'm trying to break up the pieces of a shape. So if I hit geometry object here, geometry, I think it's get parts. No, it's multi-part. Properties. I'm looking for a property in here that will allow me to get the parts of a feature. I've got part count, and I've got first point. Polygon. It's like cold up here. Let's try just printing out shape. Well, shape is just going to be a geoprocessing. Let's see if this works. Trying to get the individual parts in a shape. Okay, so it's still, when this runs through, look at what happened here. So, well, let's comment out this part. It's coming out this line right here altogether. Run that again. So are there any, look, I printed for each part in the shape, I printed a part and a row. Are there any double lines? I don't see any. Do you know of any cities in this state that are not contiguous with each other? Like Michigan is. It has two pieces.
Part of Oxford, I do know, has Jackson very connected with the airport. Is in the city of Jackson.
Okay, look at that. So see how Jackson has two lines in there?
Yep.
Okay, so you're right. There's two pieces of Jackson.
Plus there was a part on the other side of the university.
That was outside.
Yeah, but
I don't see Oxford. Maybe I'm not looking. Oh, there's Oakland.
okay.
I don't know where Oakland is.
Oakland is in Yellow County. Tallahassee County.
Look at that. Laurel has four parts to it.
Yeah, there's these little blocks that are just connect at a point to other parts of the city. I know that really.
All right, let's look at Laurel. Oops.
You were just hanging up. Right there.
That's Laurel right there, right?
Yeah. Yeah, right.
All right, so I'm sorry, what?
The running code says geoprocessing array object that has the code and
Yeah. Yeah, so, oh, sorry. What's that?
Okay, never mind, I see what I did. All right. I didn't do anything, it just looks different.
All right, so what Ken was pointing out here is that the reason why Laurel has multiple parts is because there's actually multiple polygons that make up Laurel, because Laurel is joined at just a point in a few locations. Now Jackson, is this Jackson right here?
Yeah, the Jackson's a little bit.
Yeah, look at that. The airport itself is actually in Jackson.
Well, no, it's actually, it's in Jackson, but it's between Pearl and Pearl.
Yeah, but it's like a, so Jackson is discontiguous, right? So see how that happens? See how when I hit that, these are two different polygons, but they're both Jackson. Okay. Not every state allows that. Like in California, where I grew up, San Diego is kind of discontiguous. The boundary of San Diego actually goes out over the water. So San Diego is right on the border of Mexico. And then there's two cities, National City and then Chula Vista, and then San Diego again. So it looks discontiguous. All right, anyway, that's Jackson. That's why when I say 4-part in shape, I'm getting a separate line for those cities that have multiple parts to them. Jackson's probably the best example. Laurel was in there a few times because of meeting at a point. Okay. Technically, you don't need to create a separate part for that, but it looks like they did. Okay. Now, if we wanted to go further, you'll have to think of all the different reasons why you'd ever want to do this, but if we went down a little further, we can actually get back to the coordinate systems. Okay, so now a polygon is made up, its parts are made up of what they call arrays. An array is just something that it's an object that ESRI created. Okay. But if we look at these arrays, we could get to the little components of an array. Let's see. I wonder if this would work to just say for chord in array, print chord. I think that'll work. So now an array is not defined. Okay, yeah, sorry. So the part is an array, okay? I'm just driving home this point that polygons are made up of parts. Yeah. And then this is what I need. I actually just corrected the wrong line. Sorry. Just a second. Let's watch this run. Then I'll explain what's doing here. It's going to be a bunch of stuff. Okay. All right. Every once in a while, you'll see a different line come. See those lines come through. That line right there. See that stuff happening? You're in the matrix. Okay. Those lines are when we hit a new city. We're hitting a new city. Okay. So the point I'm trying to get across is that polygons are made up of parts. Those parts, GHY calls them arrays. They're basically lists of coordinates. Okay? And so what we've done is just proven that. Okay? What we've done is looped through a series of data here. There's no reason to watch that, keep going. So what we've said here is, okay, open up a list, open up a cursor, which is basically just a series of tuples from each row, okay? Then get the shape attribute, and that's the first one, so that's row 0. Get the shape attribute, and get the shape attribute as a geometry object. In other words, I want the whole geometry. I don't want just the XY centroid, I want the whole thing. Get that whole thing and put it in this shape variable. Then, for every part in that shape, what I want you to do is print some information about it, but then I want you to get each coordinate in that part and print that coordinate. So that's what we're doing. And why do you see these are numbers, this says nan and nan. What do you think these 4 sets of numbers represent?
Coordinates for each point.
Right. This first column, what do you suppose it is? The x. The x. This coordinate is the y. This coordinate is the z. Remember, I told you that they always have a z. Whether or not you put anything in there, there's nothing that's been put in there. And it's not a 3-dimensional shape file, so there's nothing there. Then the last column is the m. Okay, x, y, z, m. So these are the coordinates that make up all those things. How many coordinates do you suppose make up all the vertices for all the cities in Mississippi? We've just asked it to print that. Okay. There's probably millions. Go ahead. Sorry, what did you say?
I was saying a lot.
Yeah, you said a lot. Exactly. So, in practice, you probably wouldn't want to loop through all of these, but there might be a reason to loop through some of them, like to go find just a particular county. Or another thing is, the example that I gave earlier, you might want to shift all of them over by 1/3 of a meter. Okay, we haven't covered putting the data back in yet. We're only getting the data, but we could do that. That wouldn't take nearly as long if you didn't print it. We printed it, but it is possible to loop through all this information. In fact, I can just, instead of waiting for this to run, I could just stop doing this and write, I think it's pass. Yeah. So now instead of actually trying to print it, I'm just going to write pass, and it's gonna run through. But notice how it's kind of jerking. The reason why I was kind of jerking, I'll run it one more time. The reason it was kind of jerking is because it's still looping through. It's still looping through each coordinate, but since it's not printing it, it's going faster. But the reason why it's going slow and fast and slow and fast is because it's reaching a big city and a small city and a big city and a small city. And so when it reaches a big city, you have to loop through all those. It's not doing anything. So it goes too fast. So another thing I could do is just go like this, print, print part, a coordinate part, okay, print part 0, okay. So this will give you an idea of what it's doing here. So now I just printed the very first coordinate from every city underneath the city. So this is the object, and I'm just getting the very first one by saying print part 0. So I'm getting the first element of this part, because remember, part is just a list of coordinates. Okay. The shapes are basically lists of parts, and then the parts are lists of coordinates. All right. Clear as mud. But you can see that pattern there. All right. What time is it? 5:31. Okay. What we're going to do now is I'm going to save this as example 3, and we're going to demonstrate an update cursor. An update cursor is going to allow us to change the data that already exists in the field. And that's really easy to do with the current code that we have. All we have to do is change this word from search cursor to update cursor. And then we have to put in some code that will actually update or make a change to the data. So change this to update. Okay. If we go back over here, go back to the original thing, we'll see the syntax for this. Okay. Look at the help here. We can basically which is an update cursor, we can basically use the equal sign as an assignment. So we're giving here in this example, we're giving the value 1 to the first field, or the second field actually, because row 0 would be the first field. Okay, so giving the value 1 to the first field. Let's actually just start with that, so you see what I'm doing. All right. So for part inch, let's delete all of this stuff. Okay. So what's the first field? Well, let's not deal with the first field because that would mess up that field. Let's deal with the second field. So row, how do we get the second field? 0, 1, 2. And we want to give it the value 1. Okay. All right. Now there's another line that we have to put in to actually get this to save. And that's cursor.update row, and we need to give it the row. Okay? That line of code, that just saves it. That's how you save it. So that's the syntax for saving that row back into the data. That's just how it's done. So we're going to run that guy. And it may not let me run it because I'm trying to access, or I'm trying to run this on, yep, look at what it says, cannot acquire a lock. It's trying to write this data into the data set. So I got to close it from our catalog. And then try to run it again. I'm not printing anything this time, so it should go fairly quick. And then acquire a lock. maybe it's because now I have several of these Python windows open. Let's try running it one more time. Okay, I have too many Python windows open. I'm going to close down all my Python windows and go to the directory. This probably happened because of the opening up the different windows. So 2006, got it with IDLE, run this guy. Pretty sure that's the reason. Let me see if there's an error in my code. Oh, one other thing that I'll check. The thing that I'm going to check this time is that sometimes when you this says that there's a lock on that data. Yeah. I'm just wondering, now that I've closed up everything, why is there still a lock? C temp M7. See all that lock, these lock files? What happens if I just delete these guys? Yeah, but I tried closing Python. Close Python down. Still got a lock file there. What is still open that is at, no? I don't want to find a solution to the problem. I have to press that, hopefully that doesn't matter. Man, that's weird. I don't have that up anywhere else. Okay. Maybe if I close all these windows down. Okay. I don't know why it's not letting me access that data, but what I'm going to do to solve the problem. You're getting a different error? How'd you get the different error? Okay, so what I'm going to do is I went into our catalog, and I'm going to copy the cities 10 layer and paste a new one. So now I've got cities 10 copy.shape. Then I'm going to change this to cities 10 copy. And since I have not used that at all yet, I haven't messed with it, I'm going to try to run it. What's that? Okay, so I tried to run it and it works. Okay, so open up our catalog again. So all I did was make a copy of the data. I mean, I could have rebooted, because rebooting would have definitely gotten rid of the lock, but that would have been silly. Okay, so what did my code do, though? What should I see that's different? What did this line right here do as I explained it? It took the third thing, but what did it do to the third thing?
Set it equal to 1.
It did. It set it equal to 1. So now when I look at the attribute table, what was the third thing? It was that ALAN 10. See that? In fact, maybe it's kind of a good thing that we had to keep the old one. Look at this column. All of this column right here. All of the values are 1, right? When I go over to the original and I go to that column, where is it? Right here. Look, the values aren't 1. See that? So we just reassigned the values in that column to be new values. We basically did the equivalent of calculating a field, where we said ALAN 10 equals 1. Have you all done calculate field, run that tool in our GIS before? Yeah, right? You know what I'm talking about?
Yeah, that. Yeah.
Right click. Oh, you can't do it in you can't do it in ArcMap. So you right click, you say calculate field, and you just say equal to 1, and then you get this thing where it says ALAN 10 is 1. So it is pretty simple and straightforward. I'm going to close our catalog. I could set it equal to anything, though. In fact, I could set it equal to, what would this do, just for practice? Okay, what's that? What would that do? Da, na, 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 na. The second row, the second what? Which is what? That's right. It would ask the length. What's that? Name 10. Okay. So what is that effectively in this case?
City.
Yeah. So what's the length of the city?
The number of characters.
The number of characters in that city name, and what's it going to do with that?
Third.
Yeah. So we're going to have a new column, not a new column, but it's going to take that field, and it's going to update the values in that field with the length of the city character. So now that it ran, so our catalog. We go here, and now we look at that column, that ALAN 10 column. Let me make this bigger. Let's just get rid of that guy for a second. Make this one smaller. Okay, so when it says ALAN 10, let's find it. Oh, that's
right there.
So it's this column though, name 10. So Collins, how many letters in Collins? There are 7 letters in Collins. Okay, there are 10 letters in West Point, and that includes a space, right? And so Snow Lake Shores has 16 characters. Again, the application of what we're doing here is obviously so great that it's hard to come up with different applications. But basically we can manipulate, we can basically calculate the fields, including we could get some metric of the geometry. In other words, we could calculate the ratio of the area to the perimeter. And we could find out which county has the biggest area to perimeter ratio or the smallest area to perimeter ratio. What would that do? Like, yeah. So the area shape perimeter will change, and if it's a really long, narrow city, we're going to get a different value than if it's a very compact city. So we could see how compact things are. We actually did this in another class that I teach, the vector class, and we found out that I don't know how to pronounce it, but Piohachi was the least compact city.
It's all along I-20 looks at the carpet. So they were trying to say, look at how big our city is.
Okay, we didn't know exactly what the reason was. So they're trying to find they're trying to make sure that the car plant was within their city. Okay. Somebody hypothesized that it might be for speeding ticket revenue. Okay. All right, cool. That sounds interesting. So anyway, it was the least compact city in the state of Mississippi.
I'm sure it has better ground than too.
Yeah, I forgot which one was the most compact, but there's a lot of runners. Like there was some city that's almost a circle.
Right there between Jackson and Vicksburg. I just yeah, right there. Yeah. Down. It's just weird.
Yeah. Anyway, in South Carolina, a lot of this, like the South Carolina is where I came before I moved here. A lot of the cities were actually defined by a point, and everything within 5 miles is within our city. Yeah, exactly.
Delaware, that's how the.
So we could find out anything about. We could basically calculate a new field based on any other combination of the attributes. Yeah. Oh, you had a question? Sorry.
I just wanted to see your code. It wasn't working for me.
Okay. All right. Well, great. Well, the code is up now, and there are lots of applications for this. One of the things that we'll do in the lab is practice those a little bit further. We'll take like a 10-minute break. I'll leave the code up while we take the break, and then we'll talk about what we're going to do in the lab, which is basically take all those points and turn them into polygons. So we're going to write a script that goes through and loops through each of the points, and then based on their attributes, we'll assign them to a different group, and basically those will become lines in another attribute table. They'll be output as lines. So we're going to practice building those, and then that's it. So let's take let's just come back right at 6 o'clock since it's 5:47, and then we'll do the lab portion of the course. I'll leave that up. Can you read that now, Bryce?
Yeah.
Okay. All right, let's just leave that up during the break. If you have a question, we'll come back from the break about it once you type it up. See if it works, and you can ask some questions.
One of the other people I know took the pictures of San Francisco.
Oh, and AG.
Yeah.
San Francisco is a beautiful city.
I went there last time and was there.
Last time I was in San Francisco?
Yeah. Like 08. I went for my session. That's the only time I ever set foot in the AAG itself. The rest of the time I just toured the city.
Oh, yeah.
Oh,
Yeah, we did that once with a conference. It was in Alaska. It was in Anchorage. And it was funny because the keynote, the keynote's always some guy that talks on something. Anyway, he was coming from Asia, and it was during, this was like in early 2000s, and it was during the SARS outbreak, and so he couldn't show up. And so their substitute was this guy from the Alaska Tourism Bureau or something, and he just talked about how awesome all these things were in Alaska, and we're like it was like 4 graduate students. We looked at each other. We're like, yeah, let's go. So we pooled all our money. We rented a minivan. We just drove around Alaska for 3 or 4 days.
I know that CCAC was in West Palm, wherever that was. There were some kids in Marshall, and I almost went with them. They decided, because they all presented on the first day. I think it was a 3-day thing. And so they were like, all right, tomorrow we're going to drive all the way to Key West.
They did it?
Because they're like, oh, it's just right there. No, it's like 3 hours.
Oh, it's a long way, yeah. All right, so did this code work for everybody that tried to run it?
I need something wrong, but I get that.
What did you say, Brett?
You gave me an error earlier.
It did give you an error.
Tuple object does not support item assignment.
Okay, so my guess is your error is in this line. Is that line exactly the same? Are these brackets or those? For me, they're brackets. Making sure they're brackets for you.
I've got brackets where you've got brackets. I've got yeah, it's the same.
Okay.
Let's see, row 2.
All right, well, my next guess is that somehow this line doesn't look the same. The fields, like your fields are different.
No, they're the same too. Wait, sure. I spelled shade differently. That might be it. Or it's not, mine's not all capital, but that didn't seem to affect the last 4 times.
All right. Well, tuple. Okay. Well, I mean, if you want to just send it to me, I'll be able to look. Probably be real quick. Just send it to my email announcement. I mean, to my email. I just send it off to the email here. All right, yeah, just let me know when you send it. Okay. Bam.
Oh, you only got 2,900 emails.
Unread emails.
Unread.
Most of them. I mean, if it's from somebody I know, Okay. All right, so I'm going to change just the path. Try to run this guy. Oh, I see. I'll run it, but This needs to be update. So right there, Bryce. So update cursors allow you to, so yeah, now it ran. Update cursors allow you to change the values in the field. So that was the only error they had. It wasn't allowing you to update the values. All right. So, okay. So this is the assignment today. We'll just go over number 2 next week later. All right. So what we're going to do is with the other data, that point data, it actually contains 2 fields. So if we look at that point data in our catalog, still have our catalog open. So this point data right here, if you look at it, it looks like that. If you hit table, it has 2 different columns. One column's called time, and one's column's called animal. Okay, the animal just means it's a unique animal. Let's say these were tigers. So there's tiger 1, tiger 3, tiger 2, tiger 5, tiger 4, tiger 6, tiger 8. Does that make sense? We got lots of animals that we put collars on. They could have been hedgehogs or platypuses. Yeah.
How were you able to clear that lock on that file?
I was not. I had to copy it.
Did you have to? So you just copied that file, pasted it in the same folder, and then deleted the locked one?
I just didn't even delete. I didn't even delete the locked one. I just copied it, and then I started dealing with the copy. The City 10 copy. So I had to go in the code. I had to change. See the code. I'm using City 10 copy now instead of. That makes sense.
Which one did you copy? Just the shape file?
Yeah, I did it here in our catalog. And I just right clicked and said copy, and then I right clicked here and said paste. Now I have another one called copy to. But I'm gonna delete that one because I don't need it.
For data to be a flip file, make sure mine looks right.
Okay, so this is the point file. This is the way the points look. And then if I click on table, this is the way the table should look. And then you got a column called time and a column called animal. All right. And let's go back to the assignment here for a second. And so the point shape file represents animal movements acquired using a GPS collar. So first we're going to create a line shape file that contains 1 line per animal, representing the movements of that animal from the earliest time to the latest time. So it's kind of like connect the dots, okay? And so if we have all of animal 1's data, we're going to connect the dots and go from 1 to 2 to 3 to 4 to 5, just up the numbers. With animals 3's data, we're going to go from 7 to 8 to 9. But we're connecting the dots, but we're lifting the pen in between the animal numbers. Okay. All right, so that's going to be the kind of new stuff. That's something that we haven't necessarily done before. Okay. Your program should also create a polyline shapefile that represents the animal's home range. The home range will be defined as a polygon shapefile you create buffered by 1 kilometer. So how do we buffer things? Yeah, in Toolbox, but we want to run it as Python. So we just need to go back and look at the way to do that. So basically, we're going to create a new shapefile, which will be lines, and the lines will be drawn. Like let's say from here, let's say we're going to connect these guys, like that. That'll be animal 1. I don't know for sure if that's animal 1. We got those lines, but then we're going to buffer that line by 1 kilometer. That's step 2. And then finally, we're going to get a bunch of buffers, and we're going to intersect the buffers with this to figure out how much of each animal's home range is inside of a national park. And so those are the 3 steps. So 2 of the steps are kind of like what we did over the last 2 weeks. The first step involves creating a new set of movements. Okay, a new line shapefile. And the other thing that we haven't gone over so far is how to create a shapefile. Okay, now I've created. If you look, there's a field called. I mean, there's a what do you call it? There's a file. There's a file called. Yeah, there's a file called tracks.shape. Created that file called tracks.shape. And right now, the geometry that's inside of tracks.shape is empty. There's nothing there. Okay. All right, but let's say I hadn't created tracks.shape yet. So this is we need to put data into this field right here, polyline, polygon, polyline. Polyline. We need to put data into that field, and so that's one thing that we need to learn. Last semester, or the semester where you took GIS, did you talk about creating shapefiles? I mean, one way you can do it is just to say new shapefile, right? You might have been aware of that. Okay. All right, there is actually a tool called Create Feature Class. I'm going to search for it. Man. I think it's called Create Feature Class. I'm going to search for tools. All right, Create Feature Class. Creates an empty feature class. So we're going to run this guy. We're going to run Create Feature Class. That's how I actually, well, that's how I started out this. So what I'm going to do is start out with that line. So let's go back to, or did I close up? Looks like I closed up Python. No, it's right there. Go back to Python, and we're going to go File, Save As. This one will be called 2016 Raber _ George _ 1 _ 1. Okay. All right. I'm going to delete everything, and I'm going to copy this over, and I'm going to copy this command called, I'll just paste this here and let you copy it. It's called Create Feature Class. It's not even getting the whole, what is going on? Okay, that's fine. I don't need this. Okay. ArcPy.create feature class management. The out path is the location that it's going to save it to. So we need to come up with an out path. That I want you to put, whoops, I want you to put for your out path, copy all 3 of these. Okay. For your out path, I want you to put the path that you've been working with for this lab. I've got C, temp, M7, that's what I've got. So that's where I'm going to put the output. The output name is going to be called tracks.shape, and the geometry type is going to be polyline. Okay. All right. And then for template, watch what I do. I'm going to delete everything else besides template. For template, I'm going to say that is equal to, now I'm going to give it the point feature layer, the GPS points. All right. Okay, the last thing I'm going to do before I actually run this is delete the tracks.shape layer. It's got an, I've got it open twice. I wonder if that's what happened last time. Anyway, I'm going to delete this tracks.shape layer. I just removed it. So this is the code so far. So we're going to run this tool from the toolbox. Same way we did it when we did the intersect tool in last week's code. We're going to run it. And all it's going to do is create a new feature class. And it's going to use the GPS points as the, oh, I got to put the R in front of both of these, sorry. Otherwise, it reads those slashes as weird characters. Okay. So it's going to use as a template the GPS points. In other words, it's going to be in the same projection and have the same attributes. That's what the template means. So that ran through. That ran. Okay. And if I go back to our catalog, what I should have is a tracks.shape file. So now I have a tracks.shape file. And if I look at that contents there, I got nothing. But if I look at the table, I've got only the names of attributes, but no rows because there's nothing in it. It's an empty blank shape file. Okay. Let me leave that up there for a second. Oops, forgot the corner is not good. All right. So if you have that and you run that, that's where we see if you can get that up and see if you can get that running. Everybody in the class. Let me know when or if you get it running or not. Whoa, that was like a big flash. I'm sorry, Bryce. What did you say?
Mine isn't doing anything. I think she got an error code and stuff from that.
Well, if you didn't get anything when it ran, that's okay because I don't have any print statements. So you could write print done, and then see if it print quote unquote done, and then run it again, and you should get something. I'm going to get an error code this time probably because I already ran it once.
So the outcome is just going to be like where some of the
Okay, now I got that.
Right.
Error.
Now you get an error that says tracks already exist.
Because
Okay, I got the same error.
Yeah.
it's.
So one thing that you could do is just say env or arcpy.env.overwrite. I always spell this wrong. Let me see. Overwrite outputs. Yeah, arcpy. Let's make sure I'm spelling it right. Override output. All right, so I'm going to put this line in here and make this say true. I'm trying to run this again. Now I should get to the line that says print done. The only way I'm not going to get there is if, yeah, okay. So even though I have override outputs on, because I'm looking at it in our catalog, it's giving me the trouble. So now it should work. There we go. Now I got a done statement. So if you close our catalog and run this script now, Bryce, see if it works with the override output equal to true. What does your error say, Kristen?
Still telling me already exists.
Is our catalog still open?
I closed our catalog.
Oh, mine is still open.
Did you put this line in your code,
Yes,
Bryce?
when we were supposed to do the create feature in our catalog, did we actually finish that?
No, I just showed you how you can do it without Python. The equivalent. Yeah.
I got to work with Dr. River. I had overwrite capitalized.
Okay.
Not messed up.
Yeah. Yeah. Case sensitive. All right. Great. So now every time this runs, you're creating a new layer, a new empty layer. That's a new polygon layer. That's what we're doing here. Okay. And now what we need to do, let's think about what we need to do. So we've got the points, and the points are going to form the basis of our polygon layer. So we need to open one of our layers up just as a read data set, okay, using what we would call a search cursor. And then we need to open up the other data set using the only cursor type we didn't talk about up to this point. Which one? We talked about search and update. What's the last cursor type? Insert. Insert basically allows us to create new features, which is what we want to do. So we want to open up the point data set as a search cursor because we don't want to edit that one. And then we want to open up the polyline, the empty polyline data set as an insert cursor. So we're going to have two different cursors. See what I'm saying? And we need to keep track of those cursors by calling them different things. So we can call them cursor 1, cursor 2, something like that. Well, let's put that line of code in there. So now we've got our cursor 1. Whoa. Cursor 1 is going to be let's go back to this guy and copy the search cursor statement. What fields do we need from the search cursor? Really, I wonder. So this is going to be arcpy.searchCursor. We need a feature class. Let's say, go up here and say FC equals, that's going to be the name of the the name of the point shape file. Oh, we already have that there. We call it a template. So let's just change FC to template. Yeah, I did that. So this is that. And then the list of fields. We really only need two. We need the point, which is called what? Shape at XY, and we need the animal. All right. There's also one other thing that we haven't done yet. Okay. In ArcGIS, what happens if you open up an attribute table, then you go over to a field and you right click and you say sort ascending or sort descending? What happens when you press that button? Yeah, it sorts it in order. Now, does it actually change the data? Like the next time you open up that field, is it still sorted? It's not. Exactly. So you change the sort order. You can do the same thing in Python. You can actually say, I want to sort a data set on a certain field. Okay, let's look at the example here. Look at all right, look at the SQL clause argument. You can actually say you want to order by a certain field, okay? An optional pair of SQL prefixes, okay? Now you could do this without this, but this makes it a lot easier, okay? So which is that? So we got field names, then we got the where clause, then we get the spatial reference. Okay, so we just go like this, none, comma, none. It says the default value is none. Explode to points, false. And then the last one, the SQL clause, we want to put in quotes, order by, and time is the name of that field, I think. I'm gonna open up our catalog again, just to make sure. I'll take you back to here. I think this is what we're gonna do. So we're basically gonna create a search cursor, and all this extra part is doing is making sure that we're sorting this data set by time when we return the search cursor. So if I look at this field, we're sorting by this line. Okay. It's already sorted by animal, but we might want to actually say order by time, comma, animal. I think that'll work. What's that? Let me make sure this works. Oh. Oh. Nope. Yeah, no, that should work. What should say if I just say time? Fields. Just a second. Where I'm just trying to make sure that this is sorted, and I Should have figured out the quickest way to do this before class, but I did not. Okay. Yeah. Where okay. All right. Just in the interest of time, I'm going to delete the rest of that. And another thing that I need to do is say del cursor 1. The data is actually already sorted. Okay? But I need to figure out the syntax for the sorting. The data is actually already sorted. If you notice, the times already increase. They already go up, starting from the lowest to the highest. So it's already sorted by time, but I wanted to include a line in there that would make sure that it was sorted by time, even if the data wasn't in your data set sorted by time. Okay, but rather than me spend 10 or 15 minutes trying to figure out how to do that, we're just going to assume that this input data is sorted by time. Okay, all right. So run that. It is sorted by time. All right, so that runs. Okay, so we've created that search cursor. Now we need to create the insert cursor, which we'll call cursor number 2, from this data set that we just created. That's the tracks.shape. Okay, so that will be something like this. This will be an insert cursor. And then the name of the data set will be this. Outpath plus or R slash plus out. All right. So this line of code is saying, okay, we're going to create a new insert cursor. The insert cursor is going to be the data set outpath plus a slash. That's all this is saying. Plus the out name. So it'll be C temp M7 tracks.shape. But rather than having to enter in another line called like output file, now we're going to get it. So this is going to evaluate to this plus this with a slash in between.
Or out need this big underscore because up there it has an underscore. Yep.
Yes, you're right. Good point. So right here we need an underscore. Yep. All right.
And then when we double come up here like that, I was about to ask if we can delete cursor 2 also. But already did.
All right. So all we've done now is create these 2 cursors and immediately go destroy them. Okay. So now in here we need to write the code that will do what we want to do. So basically, what we want to do is loop through each of the points, and every time we get to a new animal, we want to create a new feature in this one and write out all the previous points into that feature from the previous one. So we're going through, what we do is we loop through. So let's just loop through all the points, because that'll be the easiest. Okay. So the way we can do that is just say for, let's just call it PT in cursor 1, and we're just going to go print PT 0, comma PT 1. So what's that going to do? Remember what PT is? Yeah, well, it's really a tuple. Yeah. It's a tuple, and so what's PT 0?
The first attribute.
The first attribute, which we, exactly, good job, Crystal. Exactly, it's the first attribute, and the first attribute is the shape XY. So it's the coordinate of that first point, and then PT is the animal number, the unique identifier for that animal. So when I hit run, hit OK. Sorry, it's still not what?
I was just going to assume that it wasn't actually.
So now it runs through, and this is the same data from the attribute table, except for this is the coordinate, and this is the animal number. So coordinate, animal number, coordinate, animal number, coordinate, animal. So for animal number 1, we just need to connect all these dots. For animal number 3, we need to connect all these dots. For animal number 2, we need to connect all these dots, and so on. Animal number 5, connect all these dots. You okay? Something bad happened? You got an error?
I'm sure it's some syntax error of some sort that I just did not. Initially, I put that comment, I didn't have a comment.
Insert contains the most 2 arguments. Oh, yeah. So this is the plus, not a comma.
Ah, okay. I think it was something small in that line.
Let me go back to the code so that y'all can see that.
Okay.
All right. So now we're getting a coordinate and a point. That's what we're getting here. Oops. So if we look back here, basically what we need to be doing is storing the coordinate every time until we get to a new one, and then we need to save that information out. At that point, we need to do an intersect. So like, not an intersect, an insert. So right when we get to this line, if we've been saving all of these guys, then at that point, we can take this information and shove that information into a new attribute. And then do the same thing when we get right here. Take all this information.
Draw a line based on the third item.
Well, okay, so maybe yeah.
By that.
So look at this. So let's say we do this. We've got we'll put a statement in here that says so what's the identifier? Maybe we'll just change. This will make it a little bit more clear. So let's say animal is equal to PT1, right? And cord is equal to PT0. So we have that. We have those words tied to different things. Okay. Animal, cord. In fact, if we were to write this fancier, we could just do this. No, let's not write it fancier. Okay, we've got animal and cord. Okay. So
But now on the next line, you could just say print animal cord instead of.
Yes, exactly. We could say print animal, comma, cord, or vice versa. Okay. But what we want to do here is put an if statement in that says if the last time through the loop, the animal wasn't the same animal, or it isn't the same animal, then that's when we create a new. So like if we have some pseudocode here, check to see if animal is the same as last time through the loop. If animal is different, create a new polyline and put it in the output file, which is called tracks. Okay, so those are the two things we need to do. All right, now I know it's been a little while since we've played with loops, but one thing that we could do is we could say something like, I'm going to have another variable called C animal. And C animal is going to be equal to -1 for right now. We're going to initialize it at -1. Okay. And then inside here, actually, that's what I'll do. Inside the loop, I'll say if C animal, oh, we got to do it like that. Like equal something before it goes through. Okay. If C animal is equal to -1, then C animal is going to equal PT1. Okay. All right. I don't know why I called this C animal. I'm gonna make the name a little bit easier to understand because really it's the previous animal. Now I'm going to spell out. Sometimes I don't like spelling it out because I'm such a horrible speller, but previous animal. So now the animal, if in other words, if the animals hasn't been before, the previous animal is going to be -1. Okay. All right. Then at the end of this loop, we're always going to say the previous animal is equal to the animal. That way, at the end of the loop, the previous animal always gets assigned to be different. In fact, I'll show you what I mean here. So now I'm going to print animal, previous animal, and the coordinate. So I'm printing all three of those things. Move this over to here, make this a little bit smaller. I'm going to make this a lot smaller. And I'm going to try to run this guy. In fact, for now, yeah, that's fine. It worked. Okay, so look at what we've done so far. So here, the first column is the animal. The second column is the previous animal. And so what happens is, when we go through here, we get 1, 1, 1, 1, 1, 1. Then we move on to the second animal, we get a 3. But look, everywhere where these two values are not the same, right here, right here, right here, in those places, that's where we need to do what?
Maybe you want to start a new one.
Start a new line. Okay, we need to start a new line at those places. Also, we need to write the old line out, put it in the file. So we need to do those two things there. So how could we write an if statement that would allow us to do that? So this is where it is, but we need to write it. So we need to put an if statement here. If what? Exactly right. Okay, if previous animal does not equal animal, then do the stuff that we just talked about. Do the stuff is not a technical term. So now when I run this, I'm going to get a line that says do the stuff everywhere where I need to do the stuff. So basically I've created these groups now, which is exactly what I wanted to do. Ideally I would have sorted it, but like I said, it's already sorted. The only thing that's not sorted is that animal 8 is going to be below animal 9, but that's not a big deal because animal 8's data is all together. Animal 9's data is all together. In fact, if I wanted to get the syntax for the sorting, just really quick. What's that?
That shape already exists, even though I have override.
If our catalog's still open, even if you have overwrite, it'll produce that.
Yeah.
Okay, so here, right here is where I need to write out my information. Now, to start off with, we could just write out a new line into this cursor that just had the animal number. So let me show you how we would do that. So if we said, well, first of all, we'd have to say something like new row is equal to cursor 2 dot insert row. Let me make sure I have the syntax correct because my spelling is often horrible. So let's go to insert cursor and look at the syntax for inserting a new row. It's insert row. I think I was right. Yep. Insert row. And then in order to insert the row, we just need to feed it a tuple of the values that we want to give to it. Okay. So here, for right now, I'm going to write none. And then for the animal, what number do I want to give it? Do I want to give it the animal number or the previous animal number? Think about that for a second. Okay. So look at where we're storing these guys. I mean, look at when we're doing this. We're doing it right here. Okay. So at this point, this is the previous animal, or sorry, this is the animal, and this is the previous animal here. Okay. And we want to see the information about these guys. So do we want this one or this one? We want this one, right? And this one is the previous animal. So we want to save the previous animal value out to there. Now I'm going to run this, and this time, what I'm doing is into the geometry. Cursor's not defined. That needs to be cursor 2. Sorry, cursor 2. Run that guy into the geometry field. I'm just going to feed it nothing. Oh, that needs to be a tuple. This isn't a tuple. That's going to freak out again. So this needs to be a tuple. Need to run this. All right. So now I fed it this tuple, which is an empty geometry here, and I fed it the previous animal number here. So if I open up our catalog, which I'll do for a second. Remember to close it when you're done, though. Now, if we go to tracks and we go look at the table, we've written in these fields. Animal. We've created. Remember, before we did this, it was empty. It didn't have anything at all. Now we've created 6 features, or not 6, 1, 2, 3, 4, 5, 6. We created 7 features. And we created a polyline for them, but the polyline's empty at this point. There's nothing in the polyline. Right? So that's what we did. I'm going to close this up. Okay? Because we've just given it none. What we need to give it is all of these coordinate pairs lined up. Okay? But that's another, I guess, step. Another thing. Okay, look. This is the way that we actually want to feed it to it. So if we want to create a new polygon geometry, we need to do it in this manner. Okay? We need to create an array for every part. How many parts are our geometries going to have? No. Each geometry is one row in the table. So yes, we're going to have 7 features, but each feature is going to have, we're not making complex polylines. Our polylines, they start at the beginning and the end. We don't have 5 different parts or 6 different parts. We have a single line, right? Okay, so how many parts does each line have? Just 1, exactly. So our artpy.array will look a lot like this, where there's just one list, and then there's multiple points inside that list. So yeah, we're going to create something that looks a lot like this, except for we need to do this part as a loop. In other words, we need to create this as a loop, and then this part we'll just do once, right when we're creating the shape. All right. So yeah, let's actually, I'll just cut and paste this, and you guys can. So the first thing that we need to do is realize that this field statement won't work, because according to that help, we needed to make this one, this cursor, say shape at, and this one needs shape at XY. So those will be different fields. So we can come up with fields 1 and fields 2. That might be the best way to do it. Let's do it that way. Fields 1.
Why do we have to do that?
Okay, so back at the help here. We're not inputting. Okay, here's a better way to explain it. Okay, Kristen. So here, this one, we're asking for the XY coordinate of the feature. And here, we're not inputting the XY coordinate of the feature, we're inputting an entire polyline here. So we need to import, we need to give it a geometry object. So here we need to give it a geometry object. Here it's just XY. Sorry, you were saying something?
Okay, so field 1 is going to be a point, and then field 2 is going to be a polygon.
Right. And the way that that looks in here is that field 2 is going to look like this. Shape, at, and then animal. Comma, animal. All right, so here on this line, this is the way you say, when I deal with the geometry, I want to deal with the actual nuts and bolts, the actual geometry object. Here you're just saying, I just want to deal with this as an XY coordinate, which is fine if it's a point, which the input points are, so we're fine doing that. But here we actually want to build a polyline, and so if we want to build a polyline, we have to just say, I want the shape. I want to give you a shape. And we're still going to give it the animal, so that's fine.
So now, cursor 1 to cursor 2, you have to change the fields to fields 1 and fields 2.
Right, fields 1. We could have just put this right here and this right here, but again, we're trying to get to a point where we put all of the variables at the top of the list in case it makes our script more portable to a different data set. Okay? We don't hard code things in to the line code later. Do you prefer the line stuff?
It doesn't matter.
Okay. I don't think, unless I'm in front of the screen.
I know they can see it better with the lights off.
Okay. All right. So, so this is good. I don't think we need to change anything else. What we need to do now down here is mess with this none and give it a coordinate. Okay. And we're going to give it a coordinate that's going to kind of look like this line's of code that I copied over. Okay. So basically, every time we get to this, do this stuff, we need to create a new array and feed it all the points we've been dealing with. Okay, and then we need to take the polyline and create it from the array, and we need to put that polyline right here. So this is going to say polyline. Okay. Now, this line should be fine. But we need to do this part as part of a, now this is just, what kind of data set is this with these little guys right here? What's that? Good guess, but the square brackets are not a tuple, they're a list. And the reason why it's actually better that it's a list, because we're going to add to a list. We're going to add to a tuple. Okay? So here we're going to say array is equal to something. We're just going to say X this out and say list of points. Okay. So every time through, our array is going to be equal to argpy.array, a list of points. Okay. Polyline is going to be equal to just an array. Now we can actually feed it multiple, we could put a list of arrays if we had multiple parts, but we don't have multiple parts. So that's why it kind of seems like we're doing two things to create a polygon. First, we're creating this thing called an array, and then we're creating a thing called a polygon just from one array. Why would we do that? Well, we have to do it because a polygon is made up of a bunch of arrays. And those arrays are parts. All right, so the only thing left to do is take our list of points, and we need to figure out how we create our list of points. Okay? One thing that I would propose is that every time we get through this loop, we take our list of points and we reinitialize it. Okay? Basically, we do something like this. List of points equals nothing. Or new, sorry, is equal to a list, a new empty list. See, that list of points is equal to, and we need to do that at the very beginning of the loop too. List of points is equal to an empty list. So now at the very beginning, the list of points will be an empty list. And every time we get to do this stuff, that will also equal to an empty list. So we'll empty our list of points out. How do we fill our list of points up? Okay. Well, we need to fill our list of points up every time through the loop, every single time, because every time we get to a new point, right? So somewhere down here, we write something like this. List, how do we add a new thing to a list? It's close, you're right. Append. Okay. So see what I'm doing here is I'm saying, okay, here's my list of points. I'm going to append this point onto my list of points. Now, if I ran it right now, it would append this point on. In fact, our catalog isn't open right now, so I could go ahead and run this. I'm going to run this guy. List of points is not defined. Did I spell something wrong?
The list of points doesn't have a capital O.
Oh, yeah.
So what am I supposed to append?
That's exactly right. Thanks. All right,
And
so.
the one where you define at the top of the first for statement. Well, the fourth statement.
Oh, okay. So where?
Some of them are capitalized, like
Some of them are.
where it tells you what array equals. That one is capitalized. That
Okay, I'm going to uncapitalize this one. I'm uncapitalizing all, except for the P will be capitalized. Okay, so now it ran through, and if I open up our catalog, now it's going to almost work, except for what's the problem? My tracks,
They're all gonna look the same, aren't they?
they're all going to look the same, and are they even going to go anywhere? I can't even see where it is, right? I mean, they're all in the same location, and a point, a line, so it doesn't show anything. But the lines are all stacked up on top of each other because they're all using these coordinates. So instead of feeding it these coordinates, we need to feed it the coordinates from the current time through, this coordinate. I'm not sure. I don't think it'll allow me to just say coord here. But let's see if it does. I might have to say coordinate 0, coordinate 1. Yeah, point, yeah. I think there's a fancy Python way to do that. No.
It runs the first line, but it doesn't run anything else.
The first line in your.
Yeah, it gives me.
Let's see if mine did anything. Only looping through the first one. It doesn't say do this stuff. Yours doesn't. All right. I don't know why the N isn't showing up there. We'll have to figure out.
Yeah, that's an accident.
I think you did it right.
That's not what I meant. All right. So,
That's awesome.
all right.
That was well worth the price of admission right there.
All right. So this is a fancy way to write. So I could have written coord bracket 1 comma coord bracket, or coord bracket 0 comma coord bracket 1 right there. See right there. But this is a fancy way to. It's called scattering. I'm scattering the variables over there. Okay. Now, Chris, you said that yours is only running the first time through the loop. Just ran.
Yeah.
It might be because, do you have an asterisk before coordinate?
I do. Yeah. Here, I'll move this off. It's fancy syntax. This syntax would make more sense, so I'm going to do this. So coord 0 comma coord 1.
Okay, after the asterisk.
Okay. So you get the message as well.
Yeah, I had the whole list. I'm gonna look at it in Python this week, or I'm gonna look at it in R.
Yeah, see what it looks like. Okay, so yeah, I'm just gonna leave that like that. Okay. So yeah, if we look at this unfortunate message in ArcGIS, there actually is an N. Okay, there is one more animal that walks the N path. Okay, why don't you think that it? Basically, I forgot to do something. Okay, think about the output here. Okay, here's the output. Okay, when does it do its magic when it writes a new letter? When does it do that? Do this stuff, do this stuff, do this stuff, right?
Animal number 7 is not there.
Right. Well, yeah. There's one animal that's not there. It's this one, animal number 8. So it never got to a do this stuff line. It just so this part of the code, it never ran because it got to the end of the loop and it never encountered a new previous animal. Does that make sense? And so we need to take just this line of code, just these lines of code, and place them outside the loop so that it will write the last animal. So if all we do is take all these lines of code and put them right here, we'll be done. So we take this, not done, but pretty close. Let's even take the do this stuff line. We put it outside the loop. And in Python, in order to put it truly outside the loop, we need to format dedent the region twice. So now it will run this lines of code. What would be a more efficient way to do that? Instead of having to copy and paste this code here, what's something that we did? We already did the loop. What's something that we did that would cause us to not have to duplicate this? Starts with an F.
A function?
Yeah, exactly. We could write a function and then just call that function. And that function could do this, all right? In fact, I'm going to go so far as to say, if you do write a function for this part, then you get extra points on this lab, okay? If you take this and put it in a function, you get extra points. You don't have to, but you can. And it would work. You would have to pass in the polyline and the previous animal. I mean, sorry, you wouldn't have to pass the polyline in, but you definitely have to pass in the previous animal to get it to work. And you might have to pass the cursor as well. Anything, sorry, were you about to ask a question, Crystal?
Yeah, I have two questions. Well, in our catalog, it doesn't come up with anything in the previous thing.
Okay, nothing comes up. All right. All right, what was your other question?
To make a function, like return a value, or a value, like, but I don't know if we've done functions yet. I don't remember.
Yeah, we did functions earlier.
Is it like a void function?
This would definitely be a void function. You wouldn't need it. You wouldn't need it to return anything. So this is the message you should get. Okay.
I think
it almost more.
I'm gonna miss something in code.
Yeah. Now, if you want to send me your code right now, we can do that, and I can look and see what the issue is. But yeah, I'm not gonna demonstrate the writing the function right now. But if you want to look back through the book,
List of points
or
on the
ask me later.
archive. You have a capital P. Is that reference to something else previously?
Where?
Right above the red, where you commented out, check to see, right above there, you have a capital P in the word point.
Right.
Is that reference to something else?
ArcPy.point is a.
That's the command for that.
Yeah, so it's creating a point, an ArcPy point.
Okay, that was my problem.
And it takes two. It's a function that takes two parameters. Yeah. Okay, so before we let out today, if you want to send me this, that's a different subject. Send it to me and we'll look through it right now. But before we do that, I want to talk about completing the lab. So in order to complete this lab, what do we need to do? Well, we need to buffer the output. Which layer do we need to buffer at this point?
That would be the tracks layer.
Yes, we need to buffer the tracks layer by 1 kilometer. The units are already in meters, so buffering it by kilometers is just 1,000 meters. You can buffer it. So you need to put a line of code in here. I'll put that down here at the bottom. You know, run buffer tool. Okay, I'll comment that out. And then you need to do one other thing. You need to run another tool to figure out how much of how much of the home ranges, the 1 kilometer buffers, are inside of national parks. Okay, so how would you do that? It's an overlay, right? So you're doing an overlay, and then you're going to calculate the area. So you need to run 3 other tools. And all of these examples, so all that code is in previous labs. So you're going to run the buffer tool, you're going to run the intersect or union tool. Either one will work actually, but intersect will give you only the area inside of the national parks. Union will give you the area inside and outside of the national parks. Okay, and then you need to calculate field. Actually, here I'm going to add another one. Create field for area. Calculate field area. Calculate field area with area inside. So basically, you need to calculate a new field. I spelled field wrong there. Calculate a new field for the area, or create a new field for the area. In other words, you need to create a new field. We did that. We ran the create field tool previous, and we did that last week. You need to do it again. Then you need to calculate a field area with the area inside. So in other words, your new field will have an area inside the national parks. So once you do this, go here. So let's pretend this is your buffered point layer. So you buffer these guys, and if you look at the table, you'll have a new field that you can call area. You can call it inside area, and then you'll have a value in each one. once you do the intersect to calculate that value on the view. If you do a union, you'll have inside and outside, which might be more useful, but you only need to do inside. All right, anybody have any questions about that?
Do you have that all in the document for us?
Yes, so here we go, go back. And because sometimes I'm not exactly clear here. So if you go to SPA M7, meeting 7, and you go here, so we've done, you must create a line shapefile that contains one line per animal representing the movements of that animal from the earliest time to the latest time. Okay, you did that. 2, your program should also create a polygon shapefile that represents the animal's home range. The home range will be defined as the polygon shapefile you create, buffered by 1 kilometer. So you're just going to buffer it. Okay. Then your program, number 3, your program should also find the amount of each animal's home range that is within each feature of another data set called parks. An easier way to say that is how much home range is inside a national park. Okay. Find the amount of each home range that is within a park. Think GIS intersect. I even wrote that you need it. Okay, but after you do the intersect, you still don't have the answer until you create the new field and you calculate the area for the field. The area within the thing. Now, if you saved it as a geodatabase, it would actually calculate the area automatically. If you want to do that, that's fine. That solves the problem. Okay, but if you create a shapefile output, then you'll need to create a new field, which is 1 line of code, and then you need to calculate the value that goes into that field, which is also 1 line of code. I'll show you which lines I'm talking about. So I'm going to go back to week 6, and look at this line. So this line of code right here, these 2 lines of code, what do? This one adds a new field called area. This one takes the area and calculates the shaped out area. So these 2 lines of code need to go into your field after you do the intersect. How do we do an intersect? Well, this line of code does an intersect between two features. So you're going to put your parks as one of these and your polyline buffer as another one. How do I do a buffer? Well, we don't have an example in any of our previous ones. So that one you're going to have to figure it out. But again, it's only going to be 1 line of code. It's going to say something like arcpy.buffer underscore, I don't know, I think it's under analysis too. Go look in the help and arcpy.buffer, feed it the name of the polyline shapefile, and then there's a few other parameters. That's where you'll say 1,000 as the buffer distance, and then that'll run. Okay. All right. Did you send me your code? You want me to take a look at that real quick?
Oh, I already figured it out.
Awesome. Maybe.
Yeah, I did. I'm just kind of confused about. I mean, I understand how to make a new field for the area.
Mm-hmm.
So I wanted to like look up codes for buffer. I just better help and take that buffer.
Yes. So this is the way I would do it: is go to the toolbox and find buffers under analysis, proximity, and double-click buffer, and you could go to tool help and scroll down, and here's an example of running buffer. Now it's a really complicated example. So we've got buffer. This is the name of the input. This is the name. So this is the name of the input. This is the name of the output, the buffer data set that you'll create. So you call this like tracks.shape, and this would be tracks buffer.shape. Okay? For distance field, you don't have anything, just put double quotes. For side type, also double quotes. In type, you don't actually have any of those. What you need to put is under buffer, distance, or field. Okay, so all you need to do, you can just ignore the rest of this, because these are all optional. So yours needs to be tracks.shape, tracksbuffer.shape, and then here you put something like 1,000 in quotes. Quote, 1,000 quote. Yeah, in fact, I can show you what I mean there. Okay, so this is the first step. It's still not providing too many answers. So let's go back to this guy. So if I'm going to run the buffer tool here, I'm going to run the buffer tool on tracks.shape. That's this guy. This is going to be 1,000. I'm just going to delete the rest of this. And then the output is going to be, I got to write something like, I'm going to call this track out and call this tracks buffer dot shape. And I'll put all this up on GitHub. Okay, so now I put that right there. And I got to close our catalog. And then run this guy. And so what's happening is it's doing the whole thing, but now it's also going to run this buffer. And I will see if it works. By the way, I chose 1,000 hoping that it would be a good one to choose. It may have been really bad. Yep, it was pretty bad. Let's cut that down to 100. How would I do that? And I'll change the instructions accordingly. Yeah, so I'm going to close this down. I'm going to change this to 100. File, save. Run that guy. I'm going to go into here, C courses, SPA 7, and then README, edit. So this line right here, I'm going to change this to be 0.1 kilometers. Okay. So now arc map. Oh, I didn't mean to open up arc map. That will work, but I'll have to. I'm going to open up our catalog instead. Yeah, thank goodness.
So much faster. It was 10 years ago.
Okay, so here's tracks buffer. That's better. So yeah, let's go ahead and change that to instead of 1,000 meters, 100 meters, or 0.1 kilometer. Wow. All right. All right. So one thing I'm going to do now is go here and say